recording. All right, so the goal of today is to figure out what is a square and what is a square root. You can see that, right? Oh, I can make this bigger. Yay, yay, much better. Did I start recording? Yes. Okay, so you guys understand square as a geometric shape. Look like this. It has 4 equal sides and it has 4 different right angles. It's kind of a cube, like it's your ice cube, your Rubik's cube, but in a 2D format, okay? Whenever you have a square, you will know that you have side. Let's make this measure 2, okay? If that measures 2, all sides measure 2, correct? Do you guys know how to find the area?
S squared, side squared. Like
side squared, so 2 times 2, right? Geometrically speaking, if I say this measure is 2, I can draw blocks. I have 1, 2, 3, 4 blocks, and therefore area is 4, okay? So I can say, in this case, area is 4, side is 2, and then from here I can see, oh, area is coming from 2 times 2. All good? All right. So I call this 2. So I call this 4 as my square of 2, or 2 square, right? This is a square of 2, or square of 2 per side. All right, I'm gonna throw in some terminology for you, okay? Okay, so that we understand what square is. What is a square root? Square root is a magic plant that grow in math classroom that have square roots. Besides that, square root is a symbol that looks like this. Have you seen that before? Okay, so that is a symbol for square root. Okay, if I put a 4 inside, we call this symbol square root of 4. All good? Now, square root of 4 is actually a mathematical value. Square root of 4 is 2. How did I get 2? Square root of 4. Okay, it's actually coming from this square. If this area is 4, and if this is a shape of a square, then each side is 2. That makes square root of 4 2 by definition. Okay, it's just something that you have to remember. So if if you go to like McDonald's and you want to order 2 burgers, you can say, please give me square root 4 burgers, and the person should understand you as you want 2 burgers if they have been successful in Math8. Okay. So square root 4 is identical to 2. Okay, try that in the cafeteria. If you want to order 2 orders of chips, just say, I want square root 4 chips. See if they understand you. All right, does this make sense so far? Okay, so with this, if 2 is identical to square root 4, then I can rewrite this. What's the measure here on the side? Square root 4. I can also write it that way, can I? Yeah. Okay, so we are learning a new symbol. It's like repackaging them. Okay? It's a fancy way of saying things, right? We all like things fancy. That's why girls like to wear earrings, pendants, right? Okay, so this is kind of a fancy way of saying, hey, if the area is 4, and you take a square root of it, each side is 2. Make sense? Yeah, mathematicians like things fancy. I don't know why. Eh? Yeah, but that's that. Well, here shows us the basics of square and square root. We're going to take a look at the problems and see if we can work on some harder questions. I mean, some questions from here, CA. So this is your textbook, chapter 3, just 3.1. It talks about prime factorizations, all right? So I'm gonna work on that with you, all right? Say, for instance, I have this square that is larger. I'm not gonna actually draw it two sides, but it's 144 inside, okay? That's the area. So I'm asking, hey, what is the measurement on the side? Do you have to calculate? Do you know what's the measurement of the side? Do you know on top of your head? Yes, what's your name again? Braden. What is it? 12? How about as a square root? Square root of? Same number. Okay? Just like this, right? Okay, if you were to write it as a square root, then you don't even have to think, right? But if I want to write it as integers, then you have to find out, hey, 144 equals to which number that times itself, okay? If you know your multiplication table by heart, you know it's 12, yes? But if I give you some harder numbers, it will be harder to do. But let's use prime factorization to find out why is it 12, okay? Do you guys know how to do prime factorization? Yes? Okay, so I learned my prime factorization differently than yours, but we're gonna do both ways, okay? You probably learn it this way. 144 split into 2 and 72, yes? Did you learn it this way? Okay, so 2 times 72 is 144. And from 72 is 2 times what? 36. And from 36 is 2 times 18, yes? And 18 is 2 times 9 is 3 times 3. Okay? So here are all its factors. 1, 2, 3, 4, 5, 6. Okay? So I have 4 2's and 2 3's. If I were to group this into two different groups, I would have 2 times 2 times 3, 2 times 2 times 3, and that is 12. Make sense? So that's your prime factorization. If you were to factor out all the factors and you can group them into exactly two groups of equal numbers, then you just found the root. Okay? Okay? Does this make sense? Oh, you can't see the bottom. Oh my goodness. Oh, there we go. That's better. Yes? Now, I learned prime factorization a little bit differently. Maybe you'll like this next method better. So, 144. I'm going to write an inverse division like this. Okay? So, I'm going to use prime numbers. I'm going to try these numbers 2, 3, 5, 7, so on and so forth. Try the primes, okay? See what divide into. So 144, does it divide into 2? Yes, it does. The result will be 72. Does 72 divide into 2? Yes, it does. 36. Does 36 divide into 2? Yes, it does still. 18. Does it divide into 2? Yes, it does still. 9. Okay, 9 wouldn't divide into 2. Let's try 3. Yeah, it works. 3. 3. I'm gonna go all the way so that when it has 1 left. See, everything on the side here are the factors, same as this. Okay, so in this case, if I can group this into two groups, then I have found its root. All good? All good? Okay, so also notice that here you are working with what's called perfect squares, okay? Because 4 will work nicely, but if I give you, say, if that is 3, is there any number that multiplies to 3 nicely? No? No, okay, so 3 is not a perfect square, okay? So what is a perfect square? A perfect square would be this number inside is equals to two integers that multiply to each other. All right, let's go. Let's count. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just count first 10 numbers. Okay. If I put 1 here, let's see which ones are perfect squares. Is 1 a perfect square? How do you tell? Okay, put 1 here. Is there a true number that multiply to 1? Yes.
You can do 1
1 multiply to 1, two numbers. 1 and 1. Yes? So it will be 1 and 1, right? So 1 is a perfect square. Is 2 a perfect square? Is there two numbers that multiply to 2? 3? So basically all the prime numbers will not be a perfect square. How about 4? Any number that multiply to 4? Yes, 2 and 2, so that's a perfect square. Any number multiply to 5? 6? 7? 8? Any number multiply to 8? No, 2, 4, but they are different, right? 9? Any number that multiply to 9? Yes, 3 and 3. So now you know how to find a perfect square, okay? So they are perfect squares, and they are the numbers in between that are not perfect squares. Okay, so now we have identified what perfect squares are. Let me go to the question bank and see if there are other different question types that you should be aware of. Okay, yeah, so if you have 6 and 6 multiplied to 36, square root of 36 is 6. Okay. So I think that's everything that you need to learn so far as material-wise. Oh, there are some harder questions such as this. I'll better do some of this for you, otherwise you would be challenged. I'll do this 2 questions, okay? All right. So how do we do this 2 questions? 91 plus 9 underneath this roof of square root. Yes?
So basically you have to add the 2 numbers.
You have to add the 2 numbers
so
first.
You get 100 and then square root of 100 equals 10. So that's
Uh-huh. Do you guys know grammar of math? Do you guys know that math also has grammars? No? All right. So let me show you. So I know 91 plus 9 is 100. Do you know what's wrong with this? Grammar-wise. Is that a trick question? All right. I'm missing the equal sign, okay? So this tells me that this line, it's coming from the previous line. This is important as you work your assignment, as you work your homework. Give yourself enough space to get things worked out. When you check the answer key, it's all crammed together. You don't want to write like that, okay? You want to have enough space to work out your answer. And next, square root of a 100. I'm looking for 2 numbers that multiply to 100. The answer would be 10. And that would be it. Usually when you reach your answer, I like to box my answer, okay? So that the teacher knows that's the answer to look for. Okay, so I won't be mistakenly marking wrong, right? So next one, square root 4 plus square root 100. So in this case, I'll solve this individually and then multiply them together. Square root 4, I'm looking for 2 numbers that multiply to 4. 2, yes? Is it 2? 2, yes. Plus square root of 100. 10, and the answer will be 12. Box your answer. All right, sweet. Okay, so let's do this. So these are the questions found in your textbook 3.1. You can use the textbook to get all this question down. All right, I suggest you to work first on the odd number, walk through the odd numbers 1, 3, 5, 7, so on and so forth. When you reach the end, then you go back for the even numbers. Okay? Make sure you are familiar with all the question types. Okay? So if you see you have more of the same, you could probably skip them. If you just look at the answer, you know it, you could probably skip it. But make sure you get a chance to work on every single one of them. And that's my 15 minutes. And I'm going to stop this